Geotrig, this is lesson 28. We're going to talk about factorial notation first. That is an exclamation point. It's called factorial. And it's just the product of the succeeding factors where one is the last factor. So, what does that mean? It means I have 5 factorial. 5 factorial just means 5 times 4 times 3 times 2 times 1. Which actually will be a value. What's 5 times 4? Times it by 3. Times it by 2. So it's 120 times 1, which is 120. 5 factorial is 120. Oh my goodness. There is a calculator button for this. If you are using the gray box calculator, scientific calculators, it's your second category for button 3. I want you to try this. Put 5 factorial on there. If you are using a colored calculator that's scientific, you may have to use the PRB button.
Where's that button?
Okay, you again are using a graphing calculator. So on a graphing calculator, you need to go to Math and look under the PRB section.
PROB?
Maybe, I'm not sure. You
I
have
don't have that.
something. Yep, number 4.
Oh wait, never mind.
On a graphing calculator,
So you type in math, and then you go over to PROB, and then you go down to
I want you to try both 5 factorial to see if you get 120, and also do 8 factorial to see if you get 40,320. Now remember, 8 factorial really means what again? 8 times 7 times 6, 5, 4, 3, 2, 1. So if you did not seem to know where that button was, you could just take the calculator 8 times 7 times 6 times 5 times 4. It takes a while, especially if I were to do something like 120 factorial. Now your calculator will probably yell at you for that one because it's a fairly large number probably. Say like 120 factorial. Yeah, overflow, it means it's too big. It actually gives you, okay, some people can get an answer, some can't. Now, are we ready for when this is used or how we're going to use this today? This is how we're going to do this. Oh, Mr. Konchak, didn't you just show us how to do this on our calculator? And now you're telling us not to use a calculator? Guys, listen up. Listen up. These are actually pretty straightforward and they're pretty easy. The reason we need to know this is because eventually you're going to want to put combinations and permutations together of, say, we have a group of people in this classroom. If I'm picking 8 of them out of the group, how many different ways can I put that group together? Or how many different groups of 8 can I put together that are different? So all of those types of things are going to answers, when we get to that point, are going to use formulas that end up leaving you with stuff that looks like this. So we're going to learn how to evaluate these without a calculator. You can always use the calculator to back yourself up. Here's the cool thing. Again, what does 9 factorial mean? 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of that is over now. Is everybody okay with the expanded form for everything? Hey, look at this. All of those things are multiplied on top. All of them are multiplied on the bottom. You're dividing them. So that means, can't I divide them out to cancel them? Hey guys, guess what? What's 3 times 2? What's 3 times 2 times 1? What's left?
9 times 8 times 7 times.
It.
That's it.
What's 9 times 8?
72.
72 times 7.
503.
No, without a calculator, how can I do that?
Literally multiplying it.
Wild.
Guys, watch this.
Why would I do that?
Is that okay?
Yeah.
Is that not the same thing?
It's the same thing, but why wouldn't I just do 7 times 72?
What's 7 times 70? What's 7 times 7? Add a 0.
190 plus 14.
Plus 14.
504. I just figured it out.
504. Guys, do the same exact thing for the second problem, please. So, 14 factorial is? Right? Putting all the multiplication signs in there is not the easiest. Okay. All of that is over. 6, 5, 4, 3, 2, 1 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And all of those have multiplication between them. Of course. Which ones do you want to cancel? I would cancel the 11s. Change colors. 11 down. 11 down. Hey, look at this. What's 6 times 2? Cancel the 12.
Oh, I didn't even think about doing that.
What about 1? Doesn't matter, so I'll just get rid of that number. Ooh, 4 and 14. I can cancel that and make this a 7 and that one a 2. What's 7 times? So what you're left with is a 7 times 13 on top and a 5 times 2 times 3. How many people reduced it before you started multiplying? Because if you do this, those are all the factors. Can you cancel factors now? No. So when you put it together, will you be able to reduce it? No. So therefore, you'll be done. What's 7 times 13? What's 7 times 10? 7 times 3. So 21 plus 70. 91. Over 30. Hey guys, what if I said you could have made that go faster? Let's hear about it. Right. Okay. Guys, what's the number on top, or what's the biggest factorial on top? 14. What's the biggest one on the bottom?
11.
So guess what?
14 times 11.
I'm going to do 14 times 13 times 12 times 11 factorial over 6, 5, 4, 3, 2, 1 times 11 factorial. What happens with the 11 factorials?
They cancel.
Gone. And now it cancels just like we did earlier. I don't have to sit there and write out every single factor if I know I'm going to cancel them all out. You guys see that? And here's the cool thing. I could have chosen to cancel 6 through 1 out on the top and bottom, leaving me with 11 factorial stuff. And then I could have started canceling things that way, still arrive to 91 over 30. Either way, it's going to give you the same answer. Again, I did not use a calculator. Any questions on that? Yes? No? So then I want you to do this. How can we use a calculator? This time I want you to use a calculator. But I want you to evaluate 11 times 10 times 9 times 8. Yeah. But in a way, I want you to set it up first but in a way that'll help you to multiply terms one after another very quickly. Guys, no, don't time. What do you get when you multiply them all together?
79.
Okay, so 7,920 is what you get. But, guys, I'm going to go back a page quick. What was the whole process that we were doing here? We canceled. We eliminated those because they were the same. So, wait a minute. If something's the same on the top and bottom, you're not canceling them, you're dividing the top and bottom by that 5 factorial or the 11 factorial, right? So can I bring it back? How do fractions work? What you do to the top, you have to do to the bottom. What's missing? What's missing in this sequence? 7 on, or 7 factorial. Okay, guys. I heard this. We're missing 7 factorial. That would complete the factorial. But what I do to the top, I need to do to the... That's really a 1. And it'd be 1 times 7 factorial. And then Stella goes and says, wait a minute, doesn't that just create what again? On top? What did you say earlier? 11 factorial. 7 factorial times 8 becomes 8 factorial. And then 9 factorial, 10 factorial.
11 factorial.
11 factorial over 7 factorial. Which, if you put on your calculator...
7,920.
That one took longer.
Yeah, that took way longer. No, it didn't. I mean, if you really think about it, that'd be really quick.
It makes it quicker.
We just learned it.
Wait, how did you get the 11 factorial?
Okay, everybody stop what you're doing right now. Maggie, you do your multiplication. 23 on. Everyone else does the factorial method. Tell me when you're done. Go.
23 factorial or 15 factorial? Alright, what?
What's your answer? 419. Say it again. 419. Oh. 1.97. Oh, he's got a big factor. He's got it's a big number, isn't it?
Isn't it like times 10?
Okay. 4.19 times 10 to the 10th power. Really big number. Oh, 1.9 or 4.9? I'm not sure what it is. 1.9. Sorry. Because you take 23 factorial over 15 factorial. Done. I did that. I did this with a very large set of numbers to prove a point that it would be faster in the long run to use factorials to your advantage. Now, if you did not have a calculator, you would leave it as 23 factorial over 15 factorial, knowing that's just one more step to do. If you have a calculator, then you would give me the number.
So we really don't need a calculator.
You won't need it. If I did not let you use a calculator on this test, which I shouldn't need to because the last lesson didn't use one either. So far, we do not need a calculator for anything we do.
That's really cool. Well, unless you say,
Unless you want to use it to check, that type of
I
thing.
mean, but will you be able to use a calculator on?
Okay, guys, this one is called abstract rate problems. I want everybody to make sure their shoes are tied because this is going to knock your socks off. Okay? You should be wearing socks. Okay. Now, would you guys agree that rate problems that use... okay, sorry. Let me back up. These are rate problems. Everybody should understand, if I say rate, I mean distance equals rate times time. And if you were given any two of those variables, you could solve for the third. Yes?
Yes.
We've done this in math class. You've done this in science class.
True.
Now, rate problems that use letters rather than numbers to enhance your understanding, these are called your abstract rate problems. We're taking most, if not all, numbers away. This is going to force you to have an understanding of what's going on versus just, here's a calculator, I'm just going to throw some numbers down. Abstract rate problems are usually worked in 3 steps. The statement of the problem defines 2 of the components, because you need 2 of them, which allows you to be solving for the third. Then there's a change to made in 1 or 2 components, and the value of the other is requested. So, when they give you these scenarios, they're going to, it's kind of like those direct variation equations. They start off, or maybe even better yet, guys, you remember the rate problems, the worker rate problems, where you have a certain amount of people working for so much time to complete so many jobs? And then eventually they say, hey, what happens if 4 more workers come in, but they have to complete twice as many jobs? You remember that? And you had to solve for the new amount of time? It's going to be problems like that. So, they're going to change something and then have you solve for it, a part of it. So example 1. The train traveled m miles at p miles per hour and still arrived 1 hour late. How fast should the train have traveled to arrive on time? So this is how I want you guys to approach these problems. So pay attention. It's my bug out there. Thumping. Okay. This is what I suggest that you do. I suggest you make 2 columns. Kind of like our 2-column proofs. We're going to name these columns. There are 2 things going on. The train was late. So we have a late column. And eventually the train will be
Arrived.
on time. Each one of these is going to have a distance, rate, time. Distance, rate, time. I actually like to write the distance on top because if I wanted to solve for rate or time, it's always the distance divided by rate or the distance divided by time, right? So that way, if I have distance on top, I kind of have that naturally set up. So, what we need to do now is we need to figure out, do we or are we given 2 of the first column information? The train traveled m miles at p miles per hour and arrived an hour late. So, in late, it goes how far?
1 hour. Or, well, m miles.
M miles. Do we have a rate? P. But it says that it arrives 1 hour late. So is that a -1? Is it 1?
No, it would be.
That's the thing. That has nothing to do with our time. We will take that in consideration in a second. Given M and P, can you find time? Distance divided by rate is equal to time. How about M over P? Guys, we should know that rate equals distance divided by time. Time is equal to distance divided by rate. And distance equals rate times time, which is on top. Okay. It says, the train arrives 1 hour late. Okay. But, if we had to sit back and we had to figure out how fast the train should have gone to arrive on time. So the question is, does the train's distance change if he was supposed to arrive on time versus late?
No.
No. So guess his distance. M. Do we know his rate?
No.
No, because that's what it's asking us to find. Do we know his time? Ooh, that's the question. Yeah, wait a minute. He was an hour late. And if you want to arrive on time for something after being late, you need to be there sooner, right? So instead of 5 hours, you need to be there in 4 hours. You have to subtract 1 from his time. What was his time? It was m over p. And now you minus 1. So what's the rate? Rate is
over P minus 1.
distance divided by time. What's this distance?
M.
M time.
MP minus 1.
Yes. M over P minus 1. Now here's the thing. That is the rate. But we don't accept that rate because it's not in simplified form.
So wouldn't it just be P minus 1?
That is called a what, ladies and gentlemen? A complex fraction. And how did we deal with complex fractions? We multiply the top and the bottom by the LCD. What's the only denominator in this problem? So the LCD is P. So I'm going to multiply by P over P. Or, wait, let me back up. If we wanted, we could make them all have denominators, right? I am multiplying by P over 1, P over 1. Don't forget you're multiplying to the bottom by distributing. So it ends up being MP over
M minus 1.
M minus
Oh, minus.
P over 1 or M minus P. And that's miles per hour. Okay, I want you guys to try this one on your own. A boat traveled K miles in T hours and was 40 miles short of the goal when the gun went off. So it's a race. Timed race. If the skipper tried it again, how long would it take him to reach the goal, or her, to reach if she increased her rate of travel by 10 miles per hour? Make your 2 columns. Fill in what you know to solve for the unknown. We got this, I got the distance, rate, and time set up. What are my columns being called? What's that? Trial 1, trial 2. I like to sometimes use some of the words that are in there. So, short and made the goal. Just kind of give you this idea that one of them you're not making it, the other one you are making it. Trial 1, trial 2 is perfectly fine. How far do we go? In the short.
Okay.
Okay.
Rate?
Rate, do we know it?
No.
No, okay. Time
Time is T.
is T. So therefore, are we allowed to actually figure out the rate? What is the rate? Distance over time, which is K over T. Moving on to our goal. We want to make the goal. Is K still the distance?
Yes.
No. You were 40 miles short of making the goal.
Oh, so it'd be K minus 40?
No. It'd be K plus 40. If you want to make the goal, you need to make that same distance plus cover another 40 miles. So she figures that she would make it if she increased her rate by 10 miles per hour. Yes. K over T plus 10. So time is what? Time is distance divided by rate. Complex fraction again. What do I multiply the top and bottom by? T. Multiplying by 1.
And then it'd be
Which equals?
KT plus 40T all over KT. No, just K plus 10T. And
And then that ends up being
KT plus.
hours. Because time's in hours. Because it's miles per hour, hours. Homework is page 195, 1 through 7, 10 through 12, and 23. Have a great night.